Let us start the chemistry solutions of JEE Advanced 2022 paper 2. Question number 1, which they asked in the numerical type section, what they have asked: concentration of H2SO4 and Na2SO4 in a solution is 1 molar and 1.8 into 10 to the power negative 2 molar respectively. Molar solubility of PbSO4 in the same solution, you need to find out basically x into 10 to the power negative y, where they have asked the value of y. And this is expressed in scientific notation. Some data is given. Now, if you will carefully inspect the data, always keep in mind whenever you are proceeding for a question, you should look at the given data. That helps a lot. How? Look at this. Solubility product KSP of PbSO4 has been given to me. Fine, it is sparingly soluble salt. But what else also has been given to me? Look at that carefully. For H2SO4, Ka1 is very large, but Ka2 is some value. That means through Ka2, it will be dissociating now partially, not completely, right? So let us first write the dissociation. From the first dissociation, what you will be writing? H2SO4 will completely be dissociating, right? This H2SO4 will completely dissociate, and what will it give you? H2SO4 upon dissociation will give you, through first dissociation, H plus and HSO4 minus. Till here, it is acting as a very strong electrolyte. Because of that, H plus will be 1 molar only, because you have taken 1 molar H2SO4. So from here you will be getting 1 molar H plus and 1 molar HSO4 minus, right? 1 molar HSO4 minus. But the real movie starts after this. How movie starts after this? Let us see. After this, when you will be writing HSO4 minus dissociation, you will have to write it in a equilibria form, and it will be what? H plus and SO4 2 minus, right? Now, since it is a weak electrolyte, because Ka2 has been given to me, let us write the value of Ka. Ka2 has been given to me as 1.2 into 10 to the power negative 2. It is negative 2, right? Now, let us write at initial condition what is happening. Suppose I am considering that as the initial condition. Initially, how much HSO4 minus do I have? I have 1 molar HSO4 minus. When it has not gone into second dissociation, I am considering that situation. I have 1 mole H plus, right? When this dissociation has not occurred, I am considering that situation. And how much SO4 2 minus do I have in the solution? I have been given PbSO4 in the solution. Look at that. Molar solubility of PbSO4 is also there. And I have also been given this PbSO4 2 minus will definitely be coming from PbSO4. Apart from that, where else it is coming from? It is also coming from Na2SO4, right? And since it is a salt, so whatever amount of salt is there, that will completely be dissociating. So indirectly, I have been given SO4 2 minus concentration, which is coming from Na2SO4. And that is how much, guys? That is 1.8 into 10 to the power negative 2. So you should write this over there. 1.8 into 10 to the power negative 2. Till now, I have not considered the dissociation of this, right? Now, ideally, the things that you learn in the ionic equilibrium, this question is obviously from ionic equilibrium. What do you learn? That you will be dissociating some X amount. Here, X amount will be found. Here, X amount will be found. But if you will carefully look at the data, guys, look at the data carefully. If using this data, I calculate QC of the reaction, what QC will be? Look at this carefully. QC, Q is reaction quotient, if you know, right? Reaction quotient will be what? 1 into 1.8 into 10 to the power negative 2. So it is 1.8 into 10 to the power negative 2. And here Ka is what? K is 1.2 into 10 to the power negative 2. So can you see over here, guys, that QC is actually greater than Kc, and because of that, reaction moves forward or backward? Reaction moves backward, right? That was the hidden concept in this question, and that's what makes this question very beautiful, right? So what will be happening in this question then? If you have understood this, if initial condition you have understood, then finally what will be happening? Out of 1 mole, will some amount will dissociate? Yes, but that will be in backward direction. So you will have to write negative X over here. 1 molar minus X. Here also you can write minus X. That is the simultaneous equilibrium over there. And here what you will write? 1.8 into 10 to the power negative 2 minus X again, right? And here how much HSO4 minus? 1 plus X. I hope we all are clear that why this reaction is going backwards. If you have understood this minor concept, then it is very simple question after this. What will be happening after this in this question? You will write the dissociation of PbSO4. You have some amount of SO4 minus, right? You can also see one more thing. This SO4 2 minus, that it will be dissociating from the backward reaction, that will be also common with the PbSO4. So what you will have for PbSO4? Write the PbSO4 dissociation. It will be Pb2 plus SO4 2 minus, right? This will be like this. Now, for this reaction, if I write, for this particular reaction, if I write the K data, that is 1.2 into 10 to the power negative 2, should be equals to what? 1 minus x into 1.8 into 10 to the power negative 2 minus x divided by 1 plus x, right? From here, if I assume that this reaction goes very less in the backward direction, that is as compared to 1, this x is negligible. If I consider, if x is negligible, then 1 minus x can be written as approximately 1 and 1 plus x can also be written as approximately 1. If I'm using this approximation, then what value of x I am getting from this equation, guys? This will be becoming 1 and x value I will be getting 1.8 minus 1.2, that is 0.6 into 10 to the power negative 2, and you can cross check it. 0.6 into 10 to the power negative 2 is obviously negligible with respect to 1. So yes, our approximation was also right and we have got the value of x. So you have got the value of SO4 2 minus, and that value is what? 1.8 into 10 to the power negative 2 minus x, that is 1.8 into 10 to the power negative 2 minus 1 minus 0.6 into 10 to the power negative 2. So that will be what? 1.2 into 10 to the power negative 2, right? This is the value of sulfate ion in the solution. Apart from that, Pb2 plus, if I am assuming the solubility of PbSO4 is S, then this will be the total concentration of Pb2 plus and SO4 2 minus in the solution. You may be asking me, sir, why you didn't write S over here? You can write, but that will be negligible as compared to this. Why S will be negligible as compared to this data which is already available? Because you have been given KSP of this salt, which is 1.6 into 10 to the power negative 8, which is very less. That means amount of SO4 2 minus that will come from PbSO4 can be ignored as compared to amount of SO4 2 minus which is already present, that we have calculated from there, right? So that's why S is not required, not mandatory over here. If you are done understanding till this step, then our job is done. We will simply write the S into 1.2 into 10 to the power negative 2, that is KSP expression, should be equals to 1.6 into 10 to the power negative 8. After that, S will be what? 1.6 by 1.2, 1.6 by 1.2 into 10 to the power negative 6. Now this will give you some value, right? It will be giving you some value, and it will be 4 by 3. So it will be 1 point something, and apart from that, here it will be 10 to the power negative 6. So is it the value of solubility, molar solubility of PbSO4 expressed in scientific notation? Yes, there will be something 1 point, some decimals will come over here after decimal, and 10 to the power into 10 to the power negative 6, right? So this is what? Scientific notation, right? Scientific notation value of solubility. So according to scientific notation, if you compare, what is the value of Y? Y we are getting 6. So the answer to this question is what, guys? The answer to this question is 6. I hope we all are crystal clear with this. Let us now start question number 2. What question number 2 says? An aqueous solution is prepared by dissolving 0.1 mole of an ionic salt in 1.8 kilogram of water at 35 degrees Celsius. The salt remains 90% dissociated in the solution. Vapor pressure of the solution is 59.724 mm of Hg. Vapor pressure of water at 35 degrees Celsius, that is pure water, has also been given to me, 60 mm Hg, and the number of ions present per formula unit of the ionic salt question is asking. If it is asking number of ions, I can assume the salt to be of the kind of what? It can be assumed as AN kind of salt which dissociates into Na, like this, right? This is very simple question from the solutions chapter. You must have understood what is happening in this question. It has been given that pure vapor pressure of the solvent has been given and that of solution has been given, and you can write the relative lowering in vapor pressure and you could proceed. But only problem over here is what? That the salt is dissociating and 90% is the you can say dissociation extent or the alpha. So alpha has also been given. What is alpha? Alpha is 90%, or if you want to write the exact value, it is 0.9, right? Degree of dissociation has been given to me, right? Now further, I need to write the value of relative lowering in vapor pressure, but there is little problem in that. The little problem is what? If you write, we use two expressions for lowering in vapor pressure. For RLVP, we write relative lowering in vapor pressure is equals to mole fraction of solute. And there is one more formula, that is what? That is like this. If you know this, that P naught minus PS, that is pure vapor pressure minus vapor pressure of the solution divided by PS. This is not relative lowering of vapor pressure. This is just another formula that we use, where we use moles of solute by moles of solvent, right? This is the formula that is used also in the relative lowering in vapor pressure topic. Now, this is not relative lowering in vapor pressure, but it can be used. Why I am using this formula? Because here moles of solute will be some effective moles which will come after dissociation, right? So after dissociation, some moles that come, I can directly use them over here instead of the relative lowering of vapor pressure formula, where I have to use what? Mole fraction, right? So calculating mole fraction is quite difficult for such cases where salts dissociate with some extent. As compared to that, you can proceed with this. Now for this, you need effective moles of solute. So you will have to multiply it with either I and write moles of solute, or write effective moles of solute. For such formula, you must have done the value of I comes out as 1 plus n minus 1 into alpha, right? Alpha is 0.9 over here. So 1 plus n minus 1 into 0.9, right? Further, when you will be solving it, 1 minus 0.9, that is 0.1 plus 0.9 n, right? Where n is the number of ions in which one formula unit of the salt dissociate. Basically, the number of ions that it is asking, that is what n is, right? This is value of I. So here, I have got the value of I. From this, can I get the mass of the amount of solute particles? Yes, I can get moles of, if you want to write moles of solute particles which are non-volatile, right? Solute particles which are non-volatile, that will be what? That will be equals to, first we will have to go with the 0.1 mole that has been given, but since it is dissociating, it needs to be multiplied with what? I. So it will be 0.1 into I, that is 0.1 plus 0.9 n, right? And you will be getting 0.01 plus 0.09 n. So this is the moles that we have got. These are the effective moles which are present in the solution, and you can directly put this value over here. So what you will be getting, P naught is given to me 60 mm of Hg, minus PS has been given to me 59.724 divided by 59.724 divided by 59.724. After that, what will be coming? Moles of solute. Moles of solute is 0.01 plus 0.09 n divided by moles of solvent. Can I calculate that also? Yes, I can. Moles of solvent, solvent is water. Moles of solvent will be what? Moles of solvent will be, mass has been given 1.8 kilogram. We need to write it in grams. So 1.8 into 1000 divided by 18, which is the molar mass of water, right? So I'm getting 100 moles of the solvent. So write 100 over here, right? From this, when you will solve this particular thing, I have got the value. Value of n that you will be getting from this will be equals to 5. Now pay attention. This will be approximate value that you will be getting over here. This will not be exact value. So yes, this question, if you are solving exactly with the proper concept, then it requires tough calculations. So yes, it was involved. But if you are using the another formula, that is, if you are using this same expression, n solute by n solvent for dilute solution, there is one more thing. If you know, P naught minus PS by P naught can be written as n solute by n solvent for dilute solutions. You can write directly. If you will use this, then you get exactly 5, but question has not mentioned dilute solution. That's why we have proceeded with this particular formula. Although it involves tough calculation, but we get the answer. So this is the thing. That's how you solve it. I hope you all are clear with this. Now let us see question number 3. What question says? Consider the strong electrolytes ZmXn, UmYp, VmXn. Their limiting molar conductivity, that is conductance at the infinite dilution, has been given to me for U myp and vmxn, that is 250 and 447 centimeters square per mole respectively, value of m plus n plus p is being asked to me. That is, these m and p, their summation is being asked. Some data has been provided over here. Limiting molar conductivity of individual ions has been provided, right? Lambda naught is the limiting molar conductivity. It was given. Plot of molar conductivity has also been given for Zm and Xn. The one for which the limiting molar conductivity has not been provided, you have been given some other hint, and question is asking value of m plus n plus n, right? Now, pay attention, guys. This question is very simple question from the last part of electrochemistry that we study, and in this basically this is strong electrolyte, and for strong electrolyte we can extrapolate the curve. If you know, from by extrapolating you can get the value of what? You can get the value of limiting molar conductivity of a strong electrolyte. That is why this curve has been given to you, right? So from this curve and from the given data, what we can write? Let us first talk about the limiting molar conductivity of UmYp. So for ion we have been given Um and Yp data, and for Vm and Xn also we have been given. So let us write the limiting molar conductivity of UmYp. What it will be? U is 25, M is its there in the subscript, so 25M plus Yp. Y is where? Here, 100p, right? 25M plus 100p. That should be equals to what? 250, right? Similarly, if you talk about Vmxn, Vm, that is, this is 100, molar conductivity of V is 100, Vn plus, so it will be 100m because it is Vm plus Xn. How do we write the limiting molar conductivity summing up the ions? That's what we are doing. N, for X, what is it? 80N. You will be getting another thing, that is 440. I got two equations. Variables are how many? Variables are 3, and I need to solve all of them. That means I need third more equation. And for third equation, I have been given this graph. From the graph, how can I proceed? This graph belongs to ZmXn compound, and versus root C has been given to me, and I need to get the value of limiting molar conductivity of for this also, because I have been given the data of Z and Xn. So if I can somehow get its limiting molar conductivity, I will again write such equation from the given data and I will solve that equation. And for limiting molar conductivity, I have been provided the graph, right? So how will we do this? Here is the graph, and how will we proceed? You know that for strong electrolytes, we know the molar conductivity can be written as what? It can be written as limiting molar conductivity, that is lambda m naught minus B times root C, isn't it? I have been given this straight line. Actually, this is the equation of this straight line, and you can get it in another way also if you want, right? From this straight line, and after putting these values, if you will see, lambda m, if you put this value, you can get 336 is equals to lambda m naught that we don't know, B that we don't know, but root C we know. At 336, what is the value of root C? That is 0.04. You can write 0.04, right? That can be called as one equation. For the second point that you want to get, basically roots B and lambda m naught are unknown over here, right? So second point on the curve, 339 is equal to, again, lambda m naught that I don't know minus B that I don't know, but I know the value of the root C over here, that is 0.01, right? If you will calculate the value of lambda m naught from both these values, you will be getting lambda m naught of what? The given salt for which we are calculating this, that is ZmXn, you will be getting 340 in the respective units, Siemens centimeter square per mole, that you will be getting. Once I am done getting it, what I will do? I will simply use this data, that is 340. Using the given data, I will write. For which salt I am done calculating now? ZmXn. So what I will write? It is 340. For Z, how much it is? 50. Here M will come, 50M. For X, what is it? 80. So it will be 80N should be equals to what now? 340 that we have calculated, right? There are three equations, right? When you will solve these equations, you will get some values of M and P. You will get the value of M. I have calculated them. I have some values. M you will be calculating as 2. They are simple equations. You will be able to solve them. M equals to 2. N you will get as 3. And P you will get as 2. So I guess you all can calculate M plus N plus P. The value is simple. The answer is 7. Such a simple answer and such a simple question they have asked from electrochemistry. Now let us see question number 4. Question number 4 says what? The reaction of xenon and O2F2 gives a xenon compound P. The number of moles of HF produced by the complete hydrolysis of 1 mole of P is. Now this question is from P block of class 12th, and this O2F2 is a fluorinating reagent, right? We must be knowing about it. And there is a fantastic reaction of making XCF4. This is a very good reaction to make XCF4 from Xe. When you use other reagents to make XCF4, there are some more compounds along with it which get formed like XeO2, XeF6. But if you use O2F2, then we get very good yield of XCF4 over here. So from the first reaction, what gets formed, that I will write further. But before that, let us complete the question. So question is saying xenon and O2F2 gives a xenon compound. The number of moles of HF that you need to calculate by the complete hydrolysis of 1 mole of P that will have been produced from this. So you will write the reaction. Reaction goes like this. When xenon reacts with O2F2, you will be getting its compound XCF4 along with this O2 will be there. For balancing, you may write 2 over here and 2 over here, and now it is a perfectly balanced reaction. Further, you need to do hydrolysis of XCF4, that is make XCF4 react with H2O. Here what do you get as the hydrolysis products? You get Xe plus XeO3 plus O2 plus HF. Now you need to balance this reaction. So I have done the balancing. You all can do that. It is simple. So the balancing of this reaction gives you 3 over here, 6 over here, 2 over here, and here comes 3 by 2, and here comes 12 HF, right? This is the balancing of this reaction. Now, if you will pay attention, question is asking 1 mole of P. P is what? Basically, we need to figure out what is P. This is my P, right? So 1 mole of P gives you what? 3 moles of P, that is XCF4. 3 moles of XCF4 are giving me what? Through stoichiometry you can see 12 mole HF, right? And it is asking 1 mole. So 1 mole gives how many? It gives 4 moles HF. So answer to this question is what? 4. So this was a good question that has been asked from P block. I hope we all are crystal clear with it.
Now start this question with me and read with me this one question. The thermal decomposition of AgNO3 produces 2 paramagnetic gases. The total number of electrons present in the antibonding molecular orbitals of the gas that has the higher number of unpaired electrons is. Now let's start the thermal decomposition of the silver nitrate AgNO3. So on the thermal decomposition of this AgNO3, we obtain Ag solid and NO2 as a gas and O2 as a gas. Right, my dear students? Right? And this is the complete balance reaction which we have, students. So as we are very familiar about the nature of NO2 and oxygen, it is nothing but both are paramagnetic in nature. But this NO2 contain only single unpaired electron, but on the opposite hand, this O2 molecule contains more number of unpaired electrons than the NO2, right? So the total number of electrons present in the antibonding molecular orbitals of the gas that has the higher number of unpaired electrons is, and this one is the molecular orbital diagram of O2 molecule. And read with me, students, this one is the antibonding sigma star 1s antibonding orbital of O2 molecule and sigma star 2s antibonding molecular orbital of O2, and we have this one pi star 2py and pi star 2pz. So we have 2 electrons over here, 2 electrons over here, and 2 electrons over here. So finally we have 6 electrons in the antibonding molecular orbital of O2, and this is our final answer, 6, right? Now let's move on to next question. Now we have this one, the number of isomeric tetraines not containing sp hybridized carbon atoms that can be formed from the following reaction sequence is. Now let's start with this one, or first reaction, we have this one compound, it reacting with sodium in the presence of liquid ammonia. So this triple bond gets converted into alkene. So this one is the product of first reaction. So we have 1, 2, 3, 4. We have 4 carbon atoms over here, students. 1, 2, 3, and 4. And we have this one pi bond over here, students. And this alkyne gets converted into transalkene, right? Now let's talk about the second reaction. Now Br2 reacting with alkene and Br2 present in excess amount. So we observe 4 Br atoms. We observe 4 Br atoms get attached to O carbon atoms which have pi bonds, right? So we have over here, student, Br atom is there, Br atom is there, and we have Br2 Br atoms over here, students, right? Now, third reaction is elimination reaction. Now, it reacting with alcoholic potassium hydroxide. So, we have to form pi bond between carbon-carbon atoms. Now, students, first we have to form a pi bond over here, students, and we have to form pi bond over here, students, and we have to form pi bond over here and pi bond over here, students. Between alpha and beta carbon atom, this one is the alpha carbon atom, this one is the beta carbon atom, this one is the alpha carbon atom, this one is the beta carbon atom. Again, we have alpha carbon atom, and this one is the beta carbon atom, alpha carbon atom, and beta carbon atom. So finally, we obtain such compound with 4 pi bonds. But please observe carefully over here with respect to our question, the number of isomeric tetraenes that can be formed from the following reaction sequence is. So this pi bond or this area can show cis-trans isomerism. So because of this reason, we have 2 isomeric form of this beautiful compound, and finally the answer is 2, right? Now let's move on to next question. Over here, students, the number of CH2 methylene groups in the product formed from the following reaction sequence is, we have this one, student, alkene, and first reaction is the example of ozonolysis, and second one is the oxidation, and third one is the Kolbe electrolysis, and fourth is representing nothing but aromatization reaction. So now start with me, students. First, we have to break down a bond between carbon-carbon atom. So finally, we obtain aldehyde through ozonolysis reaction of this one alkene. So we have CH3, CH2, CH2, CHO. So when this one reacts with KMnO4, this COHO group gets converted into carboxylic acid group. So that's why we have butanoic acid. Now butanoic acid on Kolbe electrolysis, it will give N-hexane. So finally what we obtain, N-hexane. We have N-hexane. Now this situation, Cr2O3, and such temperature and such pressure, this compound gets converted into benzene ring, and we know that there are the 6 carbon atoms in benzene ring, and we have CH over here, 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 and CH over here. So finally we have only CH group in the benzene. There is no CH2 group. So finally we have 0 answer. Clear this one? Now let's move on to next question. Now we have this one question. The total number of chiral molecules formed from one molecule of P on complete ozonolysis. Now let's start, student. Let's start. We have to break down this molecule at pi bond, at pi bond, at pi bonds. Right, my dear students. So when we break down this molecule over here, student, we obtain CH3, CHO, right? When we break down this one compound through ozonolysis reaction, then we obtain CH3, C double bond O, right, attached with this one carbon atom, right, and this one has CH3 group as well and OH group as well. So this one is the product. This one is the product. Now let's talk about this one area. Now let's talk about this one product. So we have over here, student, CH3, C double bond O, CH3, C double bond O, right? So it has carbon atom. Now it contains OH group and CH3 group is there. So it contains OH group and CH3 group is there. Now we have CH, this one CHO we have, CHO we have. Right, my dear student? Right. Now let's talk about next one. Now let's talk about next one. We have 4 product over here, student. Now this product is same as second one. Same as second one. So we have CH3 is there, C double bond O. Now carbon containing CH3 group and OH group is there and C double bond O, CH3. We have to only observe the presence of chiral carbon, right? Right, my dear student? So we have to observe 4 different groups which are attached to carbon atom, right? Now let's talk about this one. Now let's talk about this one. This is something is third one. So we have this one, 5th product, which is same as this one, CH3, C double bond O, carbon, CH3, OH, and we have this one, CHO. Right now, there is no need to observe stereo or the position of both OH and CH3 group, right? Right. Now let's talk about this one, last one. We have to talk about this one, last one. So again, this one has same structure as like second one. So we have this 6th product, CH3, C double bond O, right? Carbon atom has CH3 and OH group, carbon atom, double bond O, and now CH3, right? Now the 7th one is same as first one. So finally we have CH3, CHO, right? So now let's observe chiral molecule. Now let's observe chiral molecule. This one is not a chiral molecule. Now let's talk about this one, student. Again, this one carbon atom has one group is same, one group is same. So this carbon atom has 2 same groups. That's why it is not chiral carbon. That's why it is not a chiral molecule. But if we talk about this one compound, or when we talk about this one product has chiral carbon atom. Because of one CH3 group is there, because of one OH group is there, because of one CHO group is there, and because of this one group is there. So that's why this one is a chiral carbon and this one is the molecule is chiral molecule. And again, this 4th is same as second one, so it is not a chiral molecule. And this 5th one is same as third one, so that's why it is chiral molecule because of the presence of chiral carbon. And finally, the 6th one is something or same as the second one. So again, this is not a chiral molecule, and again, this one is not a chiral molecule, right? So this is all about our answer, and answer is only 2. So 2 chiral molecules are formed on the ozonolysis of this one compound. Clear?
Now this question looks very lengthy. When you look at the question, you are shocked. You feel that the solution might be very difficult. Yes, students, but believe me, the size of the question should not fear you because your confidence level has brought you up to JEE Advanced. That means you are very confident about solving these questions, right, students? So let us understand the question first and then answer the options that are given to you or come to the correct option, right, students? It says that to check the principle of multiple proportion, that means to check the law of multiple proportion, a series of pure binary compounds of the general formula PMQN were analyzed and their composition is tabulated below. Okay, the tabulation or the data is given to you in the tabular form. The correct options is or are. Now first let us understand the tabular information or data that is given to you. In compound 1 it says that the weight percent of P is 50%, the weight percent of Q is 50%. Compound 2 has weight percent of P is 44.4%, weight percent of Q is 55.6%. And in compound 3, it says the weight percent of P is 40% and weight percent of Q is 60%. From this data, students, let us see what are the options, okay, and find out which options are right or which options are incorrect, right? Option A says that if empirical formula of compound 3 is P3Q4, then the empirical formula of compound 2 will be P3Q5. Okay, we have to prove this option is correct or incorrect, students. So don't worry. First, we'll just see what are the options and then discuss the solution one after the other, students. Okay. Option B says that if empirical formula of compound 3 is P3Q2 and atomic weight of element P is 20 given, then the atomic weight of Q is 45. We have to prove this is also true or false, students. Option C says that if empirical formula of compound 2 is PQ, then the empirical formula of the compound 1 is P5Q4 respectively. Okay, and then option D says that if atomic weight of P and Q are 70 and 35 respectively, if atomic weight of P and Q are 70 and 35 respectively, students, then the empirical formula of the compound 1 is P2Q. Okay, students, now the correct options are B and C. That means options A and D are incorrect. So we have to prove that options B and C are correct options and options A and D are incorrect. So that we are going to discuss in the detailed solution. So please be with me, students. Okay, here you can see that the data is again put forward in the solution for you. In compound 1, 2 and 3, the percentage weight of P and percentage weight of Q is given to you, students. So from this data, let us start solving for option A. For option A, let us consider that let atomic mass of element P be MP and atomic mass of element Q be MQ respectively. Okay, we are assuming this, students. Therefore, the molar ratios of atoms P and Q in the compound 3 is be what? Okay, we have to prove that the molar ratio of atoms P and Q in compound 3 is what? Okay, so let us now substitute. In compound 3, we know the percentage weight of P is 40, percentage weight of Q is 60. So 40 upon, so when you divide percentage upon atomic mass, right, you're finding out the simplest ratio. How do you find out the simplest ratio for empirical formula? You divide the given percentage by its atomic mass. So you're dividing 40 by the atomic mass MP, 60 by the atomic mass MQ. We're taking the ratio that is equal to 3:4, which is given to you. Okay, so now when you simplify 40:60, 40:60 will come as 2:3. When it comes as 2:3, then you cross multiply. When you cross multiply, you'll get 2MQ by 3MP is equal to 3/4. Okay, on simplification of this, what happens? You're going to get 4 into 2 will be 8MQ and 3 into 3 will be 9MP. So 9MP is equal to 8MQ. Okay, students, from this simplification, let us understand further. Okay, molar ratio of atoms P and Q in the compound 2 is what? The molar ratio of atoms of P and Q in the compound 2 is, substitute the percentage composition and divide by their atomic weights. Okay, so 44.4 divided by MP, that is atomic mass of P, and 55.6 divided by atomic mass MQ. Okay, students, now what we are going to do is, see how we are going to simplify this data that is given to you. So what are we doing is, we are taking 44.4 MQ is to 55.6 MP. Okay, so 44.4 MQ is to 55.6 into, in place of MP, I am writing as 8 MQ by 9. Okay, 8 MQ by 9 is MP. So MQ gets cancelled. So when MQ gets cancelled, what remains? 44.4 is to 55.6 into 8 by 9. Okay, students. So when you simplify this, okay, when you simplify this, you will get 9 is to 10. Okay, therefore empirical formula of the compound 2 is, P9Q10. Yes, this is not in accordance with the option A that is given to you. Therefore option A is incorrect, students. Right, students? So here we have proved that option A is incorrect by the mathematical calculation, which is simple calculations. Right. Next, moving to option B now. We had said that option B is correct. So we'll prove that it is correct by considering this following calculations and explanation. Molar ratio of atoms P is to Q in compound 3 is, divide the percentage composition by their atomic masses. So it is 40 upon MP divided by 60 upon MQ. The molar ratio is 3:2. Right, students? So that 40:60 on simplification become 2 and 2:3 respectively. So you'll get 2 MQ upon 3 MP is equal to 3 upon 2. Therefore, you'll get 9 MP is equal to 4 MQ. Now we know that atomic mass of P is given to you. Okay, that is given to you as 20. So MQ will be equal to, so substitute, MQ will be equal to what? 9 into 20 divided by 4, which is equal to 45. Yes, and we see that it is found to be true. Therefore, option B is the correct option. We have proved by finding out the atomic mass to be 45. Is it clear, students? Now let us understand option C. To understand option C, we consider the molar ratios of atoms P is to Q. In the molar ratios of atom P is to Q in the compound 2 is, again taking the molar ratios, we are taking 44.4 divided by atomic mass MP is to 55.6 upon MQ. So on simplification, you'll get 44.4 MQ is to 55.6 MP. That is equal to 1:1. Okay. Yes, the ratio is equal to 1:1. Therefore, we can say that MP upon MQ is equal to what? Equal to 44.4 upon 55.6. Hence, molar ratio of atoms P is to Q in the compound 1 is, okay, that will be the percentage composition. Okay. So when you consider P is to Q in compound 1, you take the percentage composition divided by molar mass. 50 upon MP is to 50 upon MQ, which is equal to MQ is to MP. Okay. Therefore, you can say that 55.6 is to 44.4. The ratio on simplification will be 5:4. Right, students? And therefore, we see that the empirical formula of the compound will correspond to P3Q4, which is also correct option. So B and C are correct options which we have proved. Now we have to prove that option D is incorrect. Okay. Statement given in option D is incorrect by understanding this explanation. For option D, the molar ratio of atoms P is to Q in the compound 1 is percentage composition divided by atomic mass. 50 upon MP is to 50 upon MQ. So the ratio will be equal to MQ is to MP. That is 35:70, which is equal to 1:2. Hence, we can say that the empirical formula of the compound 1 will be PQ2. Because the empirical formula is PQ2, but the statement given is different. Hence, we say that statement D is incorrect or option D is incorrect. So, for this particular question, option B and C are the correct options, students, right? Okay, students, now let us go to understand the solution of question number 10 of chemistry paper 2, JEE Advanced 22. Yes, sir. Let us understand the solution for 2022. That is question number 10. Okay, the question says that the correct options about entropy S is or are, okay, related to entropy S. We know that entropy S is a free energy. It's a question from your thermodynamics chapter, students. So therefore, the correct options about entropy S is or are when capital R is your gas constant, capital F is your Faraday's constant, capital T is the temperature given to you, students. Now option A says what? Option A says that for the reaction, metal solid combines with 2 H plus ions aqueous solution to give H2 gas plus M plus 2 ions in the aqueous solution. Okay, students. Now this is a redox reaction which is taking place over here, where the metal is getting oxidized to metal ions and hydrogen ions are getting reduced to hydrogen gas. For this reaction, if it says that if dE cell by dt is equal to R by F, then the entropy change of the reaction delta S should be equal to R. So we have to prove that with this information given to us in option 1, where entropy change delta S is equal to R or not. Assume that entropy and internal energy changes are temperature independent, students. Okay. Along with this, now let us see what is option B saying. It says that cell reaction, for the cell reaction, this is a cell representation that is given to you. Okay. Platinum solid, that is hydrogen gas whose 1 atmospheric pressure or 1 bar. Okay. H plus ions, concentration of the solution is 0.01 molar solution. And then you have H plus ions whose aqueous concentration is 0.1 molar solution. H2 gas. Okay. So now for this concentration cells, you have to show that is an entropy driven process. That means is entropy change positive? Is it entropy increases? We have to prove that is it entropy driven process. Okay. That means whether delta S is greater than 0. We have to prove that on option B. In option C, what it says that for racemization of an optically active compound, the delta S value is greater than 0. Again, we have to show that delta S change is positive. That means the process is spontaneous. We have to prove in option B and option C whether these processes are spontaneous. That means the delta S value should be positive and greater than 0. And option D, it says what? When delta S is greater than 0 for this particular reaction, okay, for this particular reaction where the complex is formed, where En stands for ethylene diamine. So from these 4 options, we see that option A is incorrect. That means delta S for the reaction is not equal to R. So what it is equal to, how it is incorrect will be proved. Whereas we see that options B, C and D are correct. That means we see that these are all entropy chains are positive. That means these processes are spontaneous with respect to option B, C and D. Let us understand the solution for the same, students. Okay. Now we know that delta G is equal to delta H minus T delta S. We know that this is the expression for change in Gibbs free energy. Delta G is equal to minus delta H. Delta G is equal to delta H minus T delta S. Now in place of delta S, I am replacing it with d delta G by dt, which is equal to constant pressure. We know that delta S is equal to d delta G by dt at constant pressure, and at constant temperature it will be what? It will be equal to V. Yes. Therefore, students, in place of delta S, I am substituting d delta G by dt. Now, when you simplify this, students, we also know that delta G is equal to minus NFE cell. So, therefore, now replacing it as minus NFE dE cell by dt, which is equal to minus delta S. Okay. Therefore, students, on simplifying this equation now, if you take minus NF below over here, so what is going to happen? You're going to get dE cell by dt is equal to delta S upon NF. Now, delta S upon NF will be equal to R upon F, which is given. Yes, this is given to you that dE cell by dt is equal to RF. So, therefore, we are equating that to delta S upon NF is equal to R by F. Okay, therefore, on simplification of this relation, we are going to get what? Delta S is equal to NR, because FF gets cancelled. Okay, so we have showed that delta S is equal to NR, but we have to understand now what is N over here. Now, for this particular reaction given in option A, what is it? Metal is getting converted to metal ions, hydrogen ions are getting reduced to hydrogen. The number of electrons lost and gained in this process will be 2. That means N value is equal to 2. So, when you substitute delta S is equal to NR, so delta S will be equal to 2R, right? But we have to show what? Delta S is equal to R. But here it is coming as delta S is equal to 2R. Therefore, option 1 is incorrect, or option A is incorrect, students. Hence, option A is incorrect. Now, coming to option B, when you come to option B, for the reaction, for this representation of the cell, the concentrations of the solution are given to as 0.01 molar and concentration is 0.1 molar respectively. So, to prove that this reaction is a spontaneous reaction, okay, therefore, we will consider the Nernst equation for a cell. We know that Nernst equation for a cell, E cell is equal to E naught cell minus 0.0591 upon N. Yes, that is given as 1. Okay, log of concentration 0.01 upon 0.1. Substitute the concentrations now. When you substitute the concentration on simplification, you will get it as 0.0591. Okay, E naught cell for hydrogen electrode is equal to 0. Therefore, it comes as 0.0591. Right, students? Now, we see that the E cell is positive. When the E cell is positive, we know that the process is spontaneous. When E cell is positive, delta G will be less than 0. When delta G is less than 0, the process is still spontaneous. And that time delta S will be greater than 0. Because delta H is equal to 0 for concentration cells. We know that considering all these conditions, students, we can say that option B is correct. The process is spontaneous and hence proved. Right, students? Let us move to option C. Option C says that racemization of an optically active compound is a spontaneous process. We have to show that racemization of an optically active compound is a spontaneous process where delta H is equal to 0. Therefore, similar type of bonds are present in enantiomers. Enantiomers are optically active compounds. Yes? When you mix equal amounts of dextro and levo form of the optically active compound, it forms a racemic mixture. Therefore, racemization process is a spontaneous process. Hence, delta S is greater than 0. Therefore, option C is a correct option. So, we have understood option B and C are correct, but option A is incorrect. Now, let us come to option D. In option D, if you see at the reaction, this reaction is resulting in formation of a stable complex. Because it is forming a stable complex, therefore, we say the process is spontaneous. And because the process is spontaneous, delta S value will be greater than 0. Hence, option D is also correct. So, for this question, option B, C, D is correct. That is the correct option. Right, students? Now, let us understand the solution for question number 11 of paper 2 of chemistry, JEE Advanced 2022. Right, students? So we're moving to the question now. The question is an inorganic question, students. Let us see the question. It says the compound or compounds which react or reacts with ammonia to give boron nitride Bn molecule is or are. That means you have to identify, students. You have to identify from the choices which of the following choices will react with ammonia to give you boron nitride. The reactions are written for you, students. We can say that options A, B and C, these will react with ammonia to form boron nitride. We can see that with option A, when you take 2 molecules of boron, react with 2 molecules of ammonia, you'll get twice Bn plus 3H2 gas. That means boron nitride is formed in the first option. With first option it forms, right? With option B, we can see that when you take B2H6, when you take 3 molecules of B2H6 and react with 6 molecules of ammonia, okay, first you get the formation of this complex. When this complex is heated at a temperature of 200 degrees centigrade, when you heat it at 200 degrees centigrade, it will get converted to 2 molecules of B3N3H6 plus 12H2. Okay, that compound which is obtained over there. Okay, then that compound on heating at a temperature greater than 200 degrees centigrade will get converted to boron nitride, where you'll get the X molecules of boron nitride. Yes, students? So we can see that option B also converts ammonia to boron nitride. Coming to option C. In option C, we are taking B2O3. When B2O3 in the liquid state is made to react with ammonia at 1200 degrees centigrade, we get the formation of boron nitride solid with 3 water in the gaseous state. Right, students? Therefore, we can say that option D, does not form boron nitride because HbF4 when reacts with ammonia forms the complex. Okay, because it forms the complex, therefore we can say that boron nitride is not formed with option D. So A, B, C will produce boron nitride. So A, B, C is the correct answer. Okay, students, now let us discuss the solution for question number 12 of chemistry paper 2, JEE Advanced 2022. Right, students? So we are seeing the question. Okay, it's a theoretical question again, students. Here it's a knowledge-based question from your metallurgy chapter. Right, students? So let us see. The correct option or options related to the extraction of iron from its ore in the blast furnace. A very simple question, students. Yes, you are studying blast furnace from class 10th. Okay, and you should know what are the reactions that are taking place at the blast furnace at different temperature condition. So the correct options related to the extraction of iron from its ore in the blast furnace operating in the temperature range of 900 to 1500 Kelvin is or are. Okay, option A says that limestone is used to remove silicate impurity. We know that limestone is used to remove the silicate impurity. So option A is correct. Option B says what? Pig iron obtained from the blast furnace contains about 4% carbon is also a true statement. Knowledge based question, students, right? And then coke or carbon converts carbon dioxide to carbon monoxide. Yes, that is also true. We have seen in the reactions inside the blast furnace at that particular temperature range. So we can say that option A, B, C is correct. But what about option D? The exhaust gases consist of NO2 and CO. The exhaust gases do not contain NO2. The exhaust gases do not contain NO2. Right, students? So option D is incorrect. Here you can see that option A says what? Limestone is used to remove silicate impurity. That is calcium oxide combines with silica to give calcium silicate in the temperature range of 900 to 1500 Kelvin. Calcium silicate is your impurity. Right, students? Then option B says that in the fusion zone, molten iron becomes heavy by absorbing elemental impurities and produces pig iron in the temperature range of 900 to 1500 Kelvin. That is also proving that is containing 4% carbon. And option C says that coke or carbon converts carbon dioxide to carbon monoxide in the temperature range of 900 to 1500 Kelvin. But option D is incorrect because the exhaust gas does not contain NO2. Is it clear, students? So simple question. All of you might have attempted this question and got it right also.
Alright, so students, now let's discuss question number 13 from your paper 2 and the section is second. So this question says that considering the following reaction sequence, the correct statement is R. So we can clearly see this sequence reaction. If you'll solve it completely, then only we'll jump into the options which are mentioned here, which is actually talking about each and every product which is forming here. So let's discuss this. So if we clearly see that the question started with benzene, and now benzene is carrying out this process which is very much similar to you can say just like we do acylation process. So it is kind of a electrophilic aromatic substitution reaction only. You can clearly see we have here a cyclic anhydride. Now what will happen is this benzene will attack this electrophilic center. Immediately this bond will shift. This bond will come back and it will take away this leaving group. Now when it happens, what will happen? This benzene will attach to this particular site and you will be getting the compound attached here, that is C double bond O, CH2, that is this carbon, then CH2, then C double bond O, and this part has left which is giving you the carboxylic group, so OH. So this is what you get here as the product of P, in which we have carboxylic acid also and we are having this ketone group also. Now what is the next step? We know that Clemmensen reduction carries out the reduction of ketone group into an alkane. So this is your P part which is having a carboxylic group. Now let's talk about the second one. Because of Clemmensen reduction, which is zinc mercury amalgam in presence of concentrated HCl, acid will stay as it is, but this particular portion will get reduced. So we'll be getting what? We'll be getting CH2, 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 C double bond OH. So this is your option, or this is your product Q. Now once we have done this reduction process, after Q, they are saying we are making it react with SOCl2. So when we make this particular portion react with SOCl2, you will be getting a group which is COCl, that is a kind of acid halide group. So in the next step, what we will be getting is, we are treating it with SOCl2. So we will be getting benzene, CH2, 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 COCl. Now that becomes your R product. After that, we are treating it with AlCl3. Now what AlCl3 will do? Again, this benzene part will attack this electrophilic site. The presence of AlCl3 here is that it is a catalyst which is actually helping in generating the electrophile here. You can understand like this, that this particular Cl minus will be taken up by AlCl3 to generate an electrophile here, over which now benzene will attack. Now since benzene will attack, so I am clearly showing you that from this particular site, benzene attack at this electrophilic center. So this is what happens. This bond shifts here, it again come back, and this leaving group is taken up by AlCl3. So this is how we will be getting a ring structure here, which is having how many carbons? So we have 1, 2, 3, 4, 5 and 6. So I'm getting a 6-membered ring which will be directly attached to this benzene now. So what I get here is, so from this particular site, if I talk about what is the S, what I get is, I'm getting this benzene. I'm getting this benzene, and over it, I'm getting a 6-membered cyclohexane ring attached like this. Now, we can clearly see the position of this C double bond O. The position of this C double bond O is just next to this carbon of benzene. So, we can clearly make this C double bond O. Now, this is your S product. After that, we are again doing the reduction process. Again, ketone will become an alkane. So, we have ZnHg in presence of HCl. So, we will be getting benzene along with this cyclohexane ring, and that is your final hydrocarbon, right? So now let's check out the options. So if you properly see, we have acidic group here also, we have acidic group in Q also. So now if we see the options, they are saying that compounds P and Q have carboxylic acids. Yes. Compound S, can it decolorize bromine water? So if I see compound S, then we'll say that usually bromine test is the unsaturation test, but benzene will not be giving that unsaturation test. So we'll say that this option is wrong. Now considering option C, compounds P and S react with hydroxylamine to give corresponding oximes. So we usually know that if we have this carbonyl group and we make it treat with hydroxylamine, then water removal takes place, and we get the formation of oxime. That means we need to have this kind of functional group, no? So they are saying P and S, are they having any such functional group? So let's check. So S is definitely having, and if I see P, then P is also having. That means this particular option is correct. And then we have option D, which says that compound R reacts with dialkyl cadmium to give the corresponding tertiary alcohol. So we'll keep in mind that your compound R, if I talk about your compound R is this particular compound, which is the acid halide. And whenever acid halide reacts with dialkyl cadmium, you get a ketone preparation. So this is a very much specific ketone preparation between acid halide and between dialkyl cadmium. Okay, so they are saying, will it give me a tertiary alcohol? No, it will be giving ketone. So your option D is wrong here. So the answers for this question will be A and C for question number 13. Now let's talk about question 14. It says that among the following, the correct statement about polymers is R. So the statement 1 says that the polymerization of chloroprene gives natural rubber. It should be actually polymerization of isoprene, which gives natural rubber. So our statement 1 will be wrong. If I talk about statement 2, it says that Teflon is prepared from tetrafluoroethene by heating it with persulfate catalyst at high pressure. Yes, it is true that under the presence of persulfate or free radical, we get this Teflon from tetrafluoroethene under high pressure conditions. Statement 3 says that polyvinyl chloride are thermoplastic polymers. Yes, polyvinyl chlorides lie in the category of moldable thermoplastic polymers. So statement C is also right. And talking about option D, it says that ethene at 350 to 570 Kelvin temperature and 1000 to 2000 atmosphere pressure in the presence of peroxide initiator yields high density polythene. So it should be low density polythene, because these conditions which are mentioned here, if I talk about, they are for low density polythene. Because for high density, the pressure is not so high, it lies in the range of 6 to 7 atmosphere. So here again, option number D is wrong, because here the problem lies in the fact that it should not be high density polythene, it should be low density polythene. So overall, if I talk about for question 14, your answer is B and C. Now talking about question 15 of section 3, what this question says that atom X occupies the FCC lattice sites as well as alternate tetrahedral voids of the same lattice. Now the packing efficiency in percentage of the solid closest to, means we have to give an approximate answer here. So as you can see that the atom X is not only occupying the FCC lattice sites but also alternate tetrahedral voids. Now we know in FCC there are 8 tetrahedral voids. So they are saying alternate, means only 4. At 4 tetrahedral sites, we have this particular atom X sitting. So if I talk about the total X atoms, then that will be 4 because it is making the FCC lattice, plus 4 because of alternate tetrahedral voids where it is sitting. So the value of X atom is 8 in my unit cell. After that, we have to keep in mind that they are asking us packing efficiency. So for packing efficiency, we need to know a relation between radius and site. So first I'll write the packing efficiency formula, which is percentage packing efficiency is total atoms in my particular unit cell into volume of each spherical atom, which is 4 by 3 pi r cube, divided by what is the overall unit cell's volume, and obviously since it's cubic, it is A cube, and then multiplied by 100. Now before we solve this, we need to know a relation between A and R, and for that we'll keep in mind that if this is my particular cube, and we are having this X atom which is at the corner, then we know that in the body diagonals surely we have some of the X atoms sitting at alternate tetrahedral voids also. So let's say that at this particular body diagonal, we have a tetrahedral void where this X atom is sitting. Now, we know that if I see the location of a tetrahedral void in a cube, it is 1/4 distance from the corner. Now, we know that the body diagonal length is √3a. Therefore, this distance from here to here is √3/4a. And it includes what? Radius of X atom, radius of X atom. So, I can clearly say from here that √3a/4 is nothing but it is equal to 2r. So, from here I can say that radius can be written as √3/8a. I can clearly say that radius can be written from here as √3/8a, or the other way I can say is that side can be written as 8/√3r. Now, what I'll do is I'll put this 8/√3r. 8/√3r in this particular side length A, and then I'll check my percentage packing efficiency. So if I check my percentage packing efficiency now, so if I solve, it will be 8 into 4/3 pi r cube, and the side now will be 8r/√3 cube multiplied by 100. Now, if I solve this particular question, r cube will get cancelled, pi will still be there. It will be 8 into 8 into 8, so it will be 1/16, √3 will go above. So, it will look like √3/16 pi multiplied by 100. And therefore, if you solve this particular question, you will be getting an approximate answer which is 34%, which you can say that is closest to 35 from the given options which are mentioned. Therefore, for this particular question 15, your answer is second.
So now let's start your question number 16 of your paper 2 section 3. So what is given to us in our question number 16? The reaction of HCl3 with HCl gives a paramagnetic gas. First, let's do postmortem of this part, which is HClO3 with HCl. What's the product that will produce? In this case, we are going to get our ClO2 because they have given us a hint which is paramagnetic gas, and we know your ClO2 is a paramagnetic gas plus Cl2 plus H2O. First, see whether the reaction is balanced. No, it is not. I think so. Yes, it is not. 2 chlorine, 2, 3. So what we are going to do, we will make this as half. We'll make this as half. Now, as they have mentioned, this is the paramagnetic gas. So this over here will be your paramagnetic. Okay. Now let's see the next part, which upon reacting with O2 produces what? So now we are going to react your ClO2 with your O3. What's the product which will be formed? In this case, the product which will be formed will be your Cl2O6. Will be your Cl2O6 plus your O2 gas. Is the reaction balanced? No. How actually we are going to balance it? 2 over here, and I think so 2 over here. Yes, now I think so this is balanced. So we have to just see what's the product over here which is forming in this case. So just see what's the option. Cl2. Your option C is correct in question number 16. So the correct answer for your question number 16 is your option C. So now let's see the next question, which is your question number 17. The reaction of PbNO3 twice and NaCl in water produces a precipitate that dissolve upon the addition of HCl of appropriate concentration. So what? So over here we want to react your PbNO3 twice with NaCl. What's the product which will be forming over here? So your Pb and Cl, so PbCl twice plus sodium and NO3. So the product which will be formed will be NaNO3. Let's see whether it's balanced. No. So we have to make it balance. So how actually we are going to make this balance? 2 over here, so 2 and 2 over here. Now the reaction is balanced. But there is one more part. This is given precipitate that dissolve upon the addition of HCl of appropriate concentration. The dissolution of the precipitate is due to the formation of what? So over here in this part we are going to introduce the excess HCl because appropriate, adding HCl. So just write here excess, and the product which will be formed in excess, if we add, the product will be formed, will be the complex, and the product over here will be PbCl4 bracket Pb. This will be minus 2 minus, basically 2 minus. Now let's see the option A, B. So your correct option for this is your option C. So as you can see, the correct option for your question number 17 is your third option, or you can say PbCl4 is the correct option. PbCl4 whole bracket 2 minus. So students, now let's do the last question, which is your question number 18 from your paper number 2 and section 3. Question number 18, what is given to us? Over here, D-glucose should be treated with the aqueous NaOH, and we want to find the resultant mixture. As over here in the option also you can see there are 3 options given. And as we all know, whenever glucose is treated with a dilute NaOH, it converts the aldehyde group, that COH group, into your ketone group. So your keto sugars are formed. When the keto sugar is treated with again NaOH, an epimer of the glucose form, or again glucose can also form. All of this reaction are reversible. So over here we are directly going to see this part, which is basic catalyzed tautomerism through the diol intermediate. So over here, if we just found out this part, the ketone form which I was telling you, in this, if you will see over here, again when I want to change this into the aldehyde, which is COH, so there are 2 possibilities. One is this and second is this. Over here COH, COH. But you will see one point where it is differing on this point. On this side there is OH over here, on this OH is on this case. So over here all of these 3 possibilities are there. So now let's just match the option which of the following 4 option has this 3 compound, because only these 3 compounds are possible in this case. So first, all of them have COH, COH, COH. So this is not possible. Yes, 2 of them has COH and 1 again, but there is one problem, like over here. There is OH on 3 side. This is also not correct. Your third option, yes, COH, COH, OH, 2H over here, and this compound. So your correct option for your 18th question is your option C. So now we are done with all the questions in your chemistry from your paper 2 section 3.